Good afternoon. Thank you so much for sticking around for what I think is the last PDC presentation today. My name is Alan Cantwell. This is my colleague Sandra Karon. We are with Autonomous Living Technologies, otherwise known as AULI.TECH, and we'll be talking about personalized, gesture-driven assistive technology today. Sandra is wearing our Cato device. This is wearable artificial intelligence. It's an inertial measurement unit, so gyroscope and accelerometer on board. It also has a tiny machine learning AI model that recognizes gestures that we're able to then turn into commands to different systems that people would want to access. Did we skip a slide? Okay, sorry. Who saw the movie Hidden Figures about the black female mathematicians at Cape Kennedy, and I think it was 1960, who used an IBM mainframe to put John Glenn in orbit? Well, the AI model, you've all heard stories about how much processing power we carry in our pockets. There's enough processing power here, more than was on that IBM mainframe that put John Glenn in orbit. We promise this is not going to put your patient, your client into orbit, but is going to recognize their motions in space so that we can utilize that and transfer it into commands. When we talk about trained gesture models, there's the idea of having a generally trained model that people would have to be able to execute the gestures, and by gestures, I mean simple nods, head tilts, shakes, things like that, not big and pronounced. Could be other body parts. Oops, okay, I don't think anyone was hurt. We're good. And being able then to train a system to recognize the user's ability to gesture rather than forcing the user to adapt to the capability of the system. Let's move on, please. I should mention, Cato is set up, Sandra's using it as a pointer only right now, and she's engaging with Dwell Clicker 2 from SmartBox. We use Bluetooth to engage functions on different systems, which means we're OS agnostic. Doesn't matter if you're on a PC, Android, Apple products. In fact, an OB feeding arm, for example, we can set up to use remote control functions. Home automation systems we can actually access with Bluetooth to control. Our mission, our origin story, is when our founder, Spiro Koulouris, was diagnosed with ALS in 2019. Spiro was a serial inventor, innovator, had been running a startup company that he designed and invented that did video AI production for colleges and high schools for sports production. So he had a long history in using AI. When he got his diagnosis, he knew he needed to have something that was configurable and adaptable enough as his abilities changed over time. He could retrain the device to work with him rather than have to switch to a new device. The focus became wearable, affordable, intelligent inertial measurement unit, and think of it as a universal controller. A universal controller that can move from one type of computer system to another. We support 3 connections now. We expect that to grow to 5. So you can toggle from one connection to another, and they could be different operating systems, different types of systems, etc. Focus on significantly reducing impediments to living. But when I say affordable, what I've learned in this world is affordable sometimes means wimpy technology. I assure you, this is modern technology that uses AI and uses a maxed out gyroscope and accelerometer to allow us to recognize what we need to do. By affordable, what I mean is we're a benefit corporation. We're not a nonprofit, but we're mission driven, and we've locked the price points in below $200 per device, and that does manage 3 different connections. What we're going to talk about a lot more today is how to personalize it and how to use AI to learn the user's abilities. Okay? Just a very high level view of the architecture. I've talked a bit about the IMU and also mentioned the Newton AI model that is what recognizes the gestures. The model distinguishes the difference between when somebody's just normally moving a pointer and controlling a pointer versus when they actually execute a gesture like a nod, and that's when it takes that information into a neural network model to assess what it thinks has just happened. That logic is translated into intentions. The same gesture I can reuse if I'm using it with an iPad versus then I use it with a PC that has totally different accessibility, native accessibility built in. The same gesture could have a different meaning depending on what system I'm using with it. In a bit, Sandra is going to show us the user interface that allows a user to determine what actions they want to map it to. At the top level, and this is the key, sending the commands over Bluetooth. If you think about eye gaze, and we often speak of ourselves as an eye gaze alternative, you're locked in 20 to 30 inches from the camera. With Bluetooth, you got 30 feet to play with. In fact, you can have a wall. You can do it without line of sight, and sometimes the home automation system you're trying to access doesn't require line of sight. So you would have that sort of ability when needed. Let's move on, please. A little bit of a tangent. I want to introduce you to one of our interns, Brooklyn Watson. Brooklyn is a gun violence survivor. She's a young adult with Oakland Unified Schools in Oakland, California. And Brooklyn has an extraordinary amount of knowledge that came from not having the benefit of tutorials and having to use trial and error to figure out how to survive in Google Classroom as a quadriplegic with vocal impairments. So first, we want to play you about 30 seconds of just a little bit of Brooklyn's story, and then we're going to talk about the other video.
Voice control, hair control, and now eye tracking.
Nice. Yeah, I've heard you're the real technology wizard. What do you like to do in your free time?
I love to play Chess on my Mac, but when I'm not really on technology, I love playing with my two dogs, Nikia and Zoe.
Cute. And why do you want to make videos about assistive technology?
I wanted to like make videos on assistive technology because I was like kind of like growing up, and I wanted to do something like on my own with minimal assistance, and I was trying to like figure out like how to make like technology like for me so I can use it. When I looked up like online, I got on YouTube. There was like a lot of YouTube videos explaining or telling you like how to turn this on, how to use it, or like how it might look like. So when you do.
Okay, thank you. Couple of points here. We can build fantastic technology, and if we can't help people understand not only how to use it, but how to access and utilize the apps, the tools, the different systems in their life that they want to, we fail. And as a benefit corporation, we see that as a big part of our responsibility in serving community. As you can tell, Brooklyn is very passionate about what she does. Brooklyn also has a challenge in communicating. So we selected a third-party application platform that creates an AI avatar of Brooklyn. She uses Google Gemini. She can use ChatGPT and other things, but she generates her content that she wants to put in video. And if I didn't mention, we hired her as an intern to do this, but it was really about building vocational skills for her to be able to establish a career path. Some kids, the idea is, I'll be a translator. Well, AI can do that for you. You learn how to use AI to do marketing and to do education, you've really established some vocational skills. So this is not Brooklyn. This is Brooklyn's avatar that you're going to see, and notice the voice difference, please. Are you getting anything there? It's not playing? Okay, something's, okay, here.
Hey guys, and welcome back to my channel. Today I will share the top 5 assistive technologies I can't live without. These tools have significantly improved my daily life, providing essential support and enhancing my ability to interact with technology effectively. So let's dive in. First on my list is...
So again, that's an avatar. Brooklyn creates the content. Now, the reason I mentioned that, we need 20, 40, 50 Brooklyns across the country and young adult programs at school districts who want to learn to use tools like this and contribute to the tutorials to serve the community of assistive tech users. Brooklyn will be doing some tutorials teaching people how to configure their Cato if they want to use Facebook, if they want to use Instagram, if they like to control Spotify. So it's one thing to be able to access the iPad or the PC. It's another thing to have the guidance to actually be able to control the apps they want to use. Let's move to the next slide. But of course, as we mentioned, we can train a basic model for people to execute gestures, and we can provide tutorials that show them how to use it. What about the user who is not able to execute the out-of-the-box gesture on a perfect vertical or horizontal plane? So at this point, I'm going to ask Sandra to take over and show you how we train.
Hi, folks. First, I want to make sure everybody can hear me. Okay? Awesome. So like Alan was saying, where I come in is making sure that our users are able to train these really individualized gesture models. Once this capability is up and running in Cato, you can create your own account on our gesture app. What you're seeing right now is my account. These are the gestures that I've trained. And I'm just going to walk you through and show you how easy it is to add a gesture to this gesture set. We're just going to go ahead and click Add Gesture. Little bit of audience participation. Is there any particular head gesture you would like me to record live right now? Any head gesture? A nod. Okay, I see a nod. So we're going to do yes nod. You can personalize the names, so let's call it yes nod. Cato location, head, but obviously Cato can be attached to various parts of a person's body. Let's stick with head. Gesture duration, 2 seconds. It can be shorter or longer. We suggest around 2. The Cato is currently advertising its Bluetooth. So we're just going to connect to it. And there are so many other devices that people have in the area. It looks like it's just being overwhelmed. So let me go ahead and try and find it.
Hopefully in your office you have fewer Bluetooth devices to deal with.
I'm just going to refresh real quick and make sure that we're advertising on here.
One thing I'll mention, in our booth, which is in the back right corner, our founder, Spiro, was using the cursor and moving it around, and someone commented, the control and the precision you have is incredible. And he said, no, the Bluetooth interference here is terrible. It's so much better at home. So it's nice in the worst case scenario, it's nice to be able to have that sort of precision control.
Nod yes. Okay, and now we're all ready to go. So I'll show you how easy it is to actually make the gesture. This is the gesture I'm going to be making. I press start. And that was one gesture collected. We do recommend that you collect about 25 to 30 gestures, but we're going to be here all day if I do that over and over, so I'm just going to do 4. Once I've done that, those gestures and that data that was transmitted via Bluetooth from the Cato are stored in our database. And we can go ahead and take a look at what that gesture looks like. If we go back here, I'm back on my gesture homepage, and we have the head nod right over here. That's part of it. That's collecting the actual gestures. But we also need to configure it so that the gestures themselves map to specific outputs on our device. And for that, for any of you that have already used the Cato device, we have the My Cato page. Now, here, we can configure a lot of the things that Alan was talking about, like the sensitivity of the Cato, the dynamic acceleration, things like that. But I want to draw your attention to the actual gesture mouse. These are the gestures that the Cato is currently capable of, and we can pair it with certain actions. For instance, mouse action, and that can be like a left, right click, scroll wheel, and so forth. We can also pair it with a keyboard. So by executing an action, for instance, in this case, a nod up, and by labeling it as a keyboard, we can choose any sort of keyboard action that we want that gesture to do. So for instance, a keypad enter, you can press enter. You can, let's see, tab, spacebar, backspace, escape, close the window, etc. So you can see the high amount of configurability, both in the actual gestures you get to choose and what you map those gestures to.
Question? It is purely focused on motion. So there's no camera engagement with this. It's an inertial motion unit, yes. But when you use it, it can be coupled with other accessibility tools. So if you want to turn a camera gesture model on your MacBook and work it in conjunction, in fact, we highly recommend people utilize native accessibility in any platform as much as is practical and effective, and we try to be a complement to that. So if there are certain functions you can't figure out how to access through the control center on your iPad accessibility, then you may want to use that as one of the gestures you map. Was that a question? Absolutely. So full XYZ access, you can train it for any body part that the user is able to move. Because we max the gyroscope out to 500 degrees per second, and we can tune it all the way down, we have one user who only has the ability to use her index finger, so we can tune it down. We have to use it operationally as a joystick at that point. And so while we're presently doing beta trials and we're learning what different users need, we're determining how to productize those components over the next months and years, but that's the focus. Yes. Yes?
How many sensors can a person use at the same time?
Oh, you could have as many, you can pair as many of them to the same device as you would like. So typically we look at kind of three scenarios. If you're using a pointer only, you need something to click. And if you want to use dwell clicker 2, dragon speech, whatever, but we have the option to do a tapper with a Cato, so you can have a second one paired, and whether that's tapping it with your foot or tapping it with a finger or doing a gesture that sends a tap, that's a second device. And the third option is you have the full gesture mouse that builds the tapping, the scroll and hold, all that functionality directly into it. And if I didn't make this point well before, you can support 3 different connections. So it doesn't have to be the same pointer on all 3. It can be a pointer on one, it could be a gesture mouse on another, in which case you may want to have a second Cato device. And again, at the price point of between $0 and $200, we're not a medical device, we're IT. No insurance required generally, and so if somebody needs 2 or 3 or 4, maybe they want one to replace 6 switch functions they otherwise have, and so on at one Cato device you could replace those multiple switches. Everything runs on the device. all of the configuration is done through a Chrome browser. So as long as you have a device with Chrome and a USB, so you need a USB connection to download software, one of the keys is the buttons on the face we now call caregiver buttons, because the ability to toggle between connections we've now attached to a gesture rather than a button push. So if a caregiver is going to help get connected to the second device, they can come use the buttons, but we're agnostic of other platforms. So as long as it speaks Bluetooth, we have a way to access it. Other questions? Thank you all so much for your attention. Thanks for coming. And if you want to see more, back right corner booth, would love to show you more demos of what Cato can do. Thank you all.